The system has a Bode plot with a constant slope of minus 60 dB per decade for all frequencies. What is the phase margin for the system? Okay, phase margin is given as 180 plus angle of the system. Okay, G of s and H of s. He has given it is having a constant slope of minus 60 dB per decade. Okay, now minus 60 dB per decade means, okay, since we are having minus sign, that means we have poles. Okay, 60 dB per decade means number of poles is equal to 3 because each pole has minus 20 dB per decade. Okay, if you have 3 poles at origin, what does it mean? That it is having the function 1 by s cube. Okay, that means minus 3 times of tan inverse of s. Okay, now what is the phase margin here? At gain crossover frequency we have phase margin, so this is minus 270 plus 180, or you can say that 180 minus 270. Okay, minus 90 degrees is the answer. That is option C.
The given figure for an order. Here it is starting in the third quadrant, means it is type 1 and it is extended into the third as well as fourth, third as well as second. So it is in order 3, that is because one pole at origin and two non-zero poles. So order 3, that is option C, is correct. Strength of the medium given H is equals to 5 cos of 10 power 90 minus 4y. Here omega is 10 power 9 and beta is 4. V is nothing but omega by beta. That is 0.25 into 10 power 9. That is 2.5 into 10 power 9 meters per second. So here C by root epsilon r is 2.5 into 10 power 9. 10 power 8. So root epsilon r is 3 by 2.5, that is 30 by 25, which is equals to, so this is 1.2. Epsilon r is 1.2 whole square, which is 1.44. That is option C is correct. The transmission line is 20 dB and Z naught is 50 ohms. The VSWR of the transmission line is, here return loss is nothing but 20 dB means that is minus 20 dB, which is equals to 20 log of gamma. From this, gamma is equals to 0.1. VSWR is 1 plus gamma by 1 minus gamma, that is 1 plus 0.1 divided by 1 minus 0.1, which is 1.1 by 0.9, which is equals to 1.22. So option C is correct. Comes to maximum impedance, Z max is equals to Z naught into VSWR, that is represented with S, 1.22 into 50, which is 61 ohms. That is option C is correct. Has an antenna with a total noise temperature of 50 K and the physical temperature of 300 Kelvin and an efficiency of 99%. Its transmission line has a physical temperature of 300 Kelvin and efficiency of 90%. The first 3 stages of receiver all have 80 K noise temperature and 13 dB gain. The receiver noise temperature is, here receiver noise temperature is nothing but 80 plus 80 divided by 20 plus 80 divided by 20 square is equals to 84.2 Kelvin. Here this is gain is nothing but given in dB. So 13 is equals to 10 log G. So which is nothing but G is approximately equals to 20. So C is correct. The system noise temperature at the antenna is, so system noise temperature is nothing but ambient temperature, antenna temperature, ambient temperature and efficiency of an antenna minus plus transmission line temperature 1 by ETL minus 1 plus 1 by ETL into temperature of the receiver. So if we substitute all the values we will get this as a 180 Kelvin. That is option B is correct. Here the circuit is given in the figure. We have to decide what kind of function it's going to perform, whether it is going to perform decoder or encoding or multiplexing or demultiplexing. See here, if A1, depending upon the A1 and A0, D3 or D2 or D1 or D0 are going to be passed. Only one of those are going to be passed, means it is acts as a selection lines, so it is a multiplexer. So option C is correct. Comes to value of f, if A1 both are equals to 1 means C3 is going to be 1, so D3 is going to be passed to the F. So option C is correct. They are given Ni 4.55 into 10 per centimeter cube, Dn is 1950 centimeter square per second, Dp is 7.8 centimeter square per second. When the conductivity is minimum, the hole concentration is. When the conductivity is minimum, the hole concentration is Q this is Ni mu n by mu p under root. If we substitute the given values, that is mu n by mu p is nothing but here dp by mu p, dn by mu n, which is same. So here equal to 1. So dp by mu p is equals to dn by mu n. From this, mu n by mu p is equals to dn by dp. So ni under root dn by dp. If we substitute, we will get this as 7.2 into 10 power 11 per centimeter cube. Here d by mu is nothing but a Vt. So option B is correct. Comes to the minimum conductivity, sigma min is equals to 2q ni under root mu n mu p. If we substitute the given values, then we will get it as 1.7 into 10 power minus 6 ohm centimeter this, which is, this is 0.69 which is going to be 6.9 into 10 power minus 5 ohm centimeter inverse. That is, this is 6.9, this is 5, so option D is correct.